Hello guys, in this video session I will explain how to solve one of the possible coding interview tasks that usually people ask on while interviewing. Usually this kind of task, they're pretty simple, but they're not necessarily simple when you're on coding interview. So I'll go through my thought process while I'm doing this. I'm curious myself how I would go through it and see how much time and struggle it will take and what is important points to look at. Okay, let's do it. Let's define a class. First of all, the problem will be about traversing the linked list. Not traversing, but reversing the linked list. Okay, I will explain as I go. Linked list reverse demo. Let's see. I'll zoom it for you. So what is the task? What is the requirement is? The requirement is we have a list 1, 2, 3, and it's not just a list, it's a linked list. It means that each element knows about the next one. And when I say knows, I mean that it has a link to the next one. So before going any further, let's define a class that will explain what I mean by element. Element. Like in this case, the one, what it is? It is a value of this element, and it's integer value. Then it has a link to next element. Next element meaning we have a link, right? So I could have put it this way, something like that. Link to next one, etc. Okay, I'll keep it simple here. Okay, so we have a class. Let's create a constructor. So we can create an instance of it. Let's put maybe the string because I guess we'll print it. That's it. We have this element class ready for us. Let's create an entry point function. And right now let's create a element. It's gonna be head, I guess. The head means that it's the first element of the list. So in this case, this is head, right? 1 is head. So bear with me. We're gonna create this data. We're gonna using that constructor that we just created here. You see, first element value, second element is link. Then first element for the first element is value is 1, and then it points to the next element, which is 2. So this is next element 2, and second 2 element points to third element. New element 3 that points to null. Okay, that is what we just did. We just defined the data. And right now, what are the requirements again? We want this to reverse. Okay, so as soon as we reverse this linked list, we will get it reversed naturally, like that. You see, it's kind of flipped. 1 become the last, 3 become the head. So it's gonna be new head 3. Right. So let's say we have a function. We don't have it yet, but let's say we have reverse that would take a head, right? And it will get a new head. I will explain it right now. Look, we pass this data starting from head to it, and it will get us the result, this data with the head, and the head will be pointed to 3. So let's say if we print this result, we will be having something like that. To print this, um, like that, right? Just because we have a toString method here, and we will be able to print it. But we don't have yet reverse. Let's create it. Cool. And voila. And we have to do some logic in here, right? We have to reverse. So let's think about it again. So far so good. We just need to make some code. Right now, before starting doing anything, as a rule, before start coding, because right now we didn't really think, we just did some mechanical work and then the expectation will be printed there. But we have to start thinking in here. This is our logic. Okay. And because it's an algorithm, it means we have to come up with some steps. How to make these result possible. Let's define the steps if we can find them. So step 1. First of all, we know that we will be going through this list one by one, right? So let's say this is current element, then this become current element, then this become current element until the now, right? So that's already something. It gives them something. So to traverse it, we will probably do something while not now, right? And then we'll be do this flipping thing here. And what it is while not now. Who is not now? Like we said, uh, we have to have something like a current element, right? Current, because we know that it will be going through. Let's define it. Element, current element. And that is kind of important because this gives us a language. It's like our domain language in a way, right? So we know that there is a current element. It has a head, and we will be doing it until current element is not equal now. That's how we will be traversing it from the beginning to the end. But of course, this code is not doing any traversion yet. It just puts some expectation for how long it will be doing this. So for sure, this current element is supposed to be changed here at some point, right? But we don't know yet how we're gonna do it. Let's go back to the steps. So far we know that we'll be traversing. So far we know that we're gonna have a current element. And so far we know that current element points to head because we start from head to tail, right? Okay. So also we know the expectation. So let's say if current element, like at first step, at first iteration, let's put it because I'm scrolling back and forth, right? So let's put it here, easy to read. Yeah. So first step, let's remove this head, easy to read. So in first step, as we get this one as a current. We know that expected result that now one supposed to be pointed to now. So that's what we want to do on first step. One points to now. Then on second step, as current is 2, current element is 2, it's a 2 supposed to be pointed to 1. And on first step, 3 supposed to be pointed to 2. So we did this kind of steps, but let's see if we see a pattern or something. What we're doing here actually, we points 1 to now. Okay. On second one, we points 2 to 1. So right now we kind of see, you see like 2 points to 1. What does it mean? This current element points to previous element, right? So we have one more word in our vocabulary, previous element. And also this current element points to next element. So I suggest right away, before going anywhere, define this. But even before that, let's just put it somewhere. So my point is, everything that we have to do is seems to set current element to be pointed to previous element. Like in this case, look, like I said, current element points to previous element. And this points to some previous element, but we don't have actually any previous element. It's kind of null actually, right? So that means that probably this previous element is supposed to be start from null, because we know right away as we start we have to set 1 to null. Okay, let's do it. So I'm just putting this right in here in our to do. So how to make this possible? Current element to be pointed to previous element. So this is our current element, and it's supposed to be pointed to previous element. How to make it possible? Link, right? Pointed to previous element. We don't have yet previous element. So previous element is supposed to be null, like we said before. Yeah, it means, I'll show you. Let's say if current element is 1, so it's supposed to be pointed to null. And null in this case is previous element. So let's remove this comment. Another thing. Yeah, another thing. We said our vocabulary right now, we have current element, previous element, but we don't have a next one. So let's define who is next one, because for sure we will need it. Element, next element. And who is the next element in this case? Next element is our current element to whatever this link points to. Right? So let's say if it's 1, if current element is 1, it points to what? It points to 2. So then our next element is 2. Okay. But now we have it. And it's good. This is good. So we did kind of 2 steps, something like that. We did the main step, I think, pointed current element to previous here. Current element points to previous, right? And then we have to point um, right now this next element is just defined once. Mhm. We have a while, right? This while loop, and at some point we're supposed to exit it. Otherwise, it will be looping forever as we're going through it. So at some point, this current element is supposed to be pointed to now. And how to do it? It means that our current element is supposed to be pointed to next, and this is supposed to be pointed to next, to next, right? So what we have to do, that make our current element to be pointed to next element, something like that. So this is kind of strange steps, because here we said that current element points to previous, and here we're saying current element points to next element. What do we mean? What do we mean by that? 1 points to 2, 2 points to 3, and we do these steps. 1 points to 1, to now, 2 points to 1. So it's kind of previous, previous, previous. So this is that step. But we have to go through the while, right? That's why we have to change current. And the current is supposed to be pointed to next element at some point for sure. So I don't know, let's just put it because it seems like the right thing to do. Current element points to next element. Does it make sense? If we do this, we will make sure that at some point we will end with now, because we're going through, right? We're always getting next, 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 and at some point this will point to us to now. Okay, let's see. Then what is previous element? You see there is some kind of highlight that's saying that this previous element never changed. It's always now. So let's fix it. So the previous element is supposed to become next one. And in this case, next one is current one, I believe. Current one. Does it make sense? Yeah, I'm just following little steps, but sometimes like the whole picture is blur as I'm going through it. So what just happened? We're going through. Yeah, we have to test it just to see what's going on. We can debug it, but let us decide what we have to return here, because right now we return null. Null, 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 null. We're not supposed to return null, but what we can return? We're not supposed to return head because head is changing over time. We're supposed to return a new head when it's done, and this head will be 3, which means on very first step this current points to this next, and this next is current, right? Then this 3 is previous. So we're supposed to return previous. Yeah, at least let's agree on that. Let's test it. Usually it doesn't work in first run. Oh, it did work first run. Yeah, okay. So it seems like we solved this problem, even though it was kind of blur on this point. We solved this. I'll prove it to you. Let's zoom. So look, 3, 3, 2, 2, 1, 1, points to null. All right. So this is working fine. And let's summarize. Like how come that we solved this problem even though we were not necessarily were knowing exactly what we're doing and not really keeping all the steps in our head right away. Uh, just what help us is these steps for sure. So we can define them step by step, all these comments that we put. What helps us as well is our terminology, our language, our vocabulary that we defined. So it made it possible to go through it simpler without any ambiguities. Right? Um, yeah. Otherwise, it often happens then as you go and you name something with A and then with B and C, then you don't know what is what. Let's say we define here a link, right? Let's say if we rename it to something like next, it would be confusing for us because we have this next element and then this is going to be next and then probably it will cause a confusion just simply naming things incorrectly. And it happened to me before for some other tasks I've been doing recently. So these kind of important points that I can highlight. Okay, thanks for listening.